Alrighty, CNT125, our design lab. Let's take a look at what we need to do. This first podcast is going to be kind of an overview of what we need to do to tackle our design lab. First thing in our design concepts folder, down in the do area, we're going to open up the on-campus lab here. You'll notice there's a number of different links here and some resources that are going to be helpful for this. So first thing, download a copy of the network design lab. That's what I have here. You'll notice there's a link here for diagrams.net, as well as a podcast from back in 120 on how to create a network diagram with diagrams.net. There's a helpful information file. This is going to be a huge help, as well as some references for TCP UDP port numbers and private addressing. Also down here is going to be a packet tracer practice file that you can use to do some prep and planning before you come to the lab room. Alright, so I downloaded a copy of the Network Design Lab file, and we're going to take a look at that. Let's take a look through what's here. First thing is just kind of a reminder of this is basically a summary of the labs we've done this semester. We're going to try to pull all the pieces together into kind of like a real scenario. Back in 120, you figured out a network for a customer. You made a network map and you picked out some equipment and you basically came up with a simple solution for a customer. We're now going to take that one step further and actually try to implement the solution we have in mind. That's what we're going to try to do with this design lab. Take it one step further. So the first page here is the needs assessment. What does this facility need? It's a branch office. What do they need? We're going to come back to this. This talks about the computers, phones, wireless users, etc. Part 1 says we will need to come up with a network map. This is where we'll use the diagrams.net. We're going to need to communicate what our plan is. And this might be a working document. You'll have a draft of this and you'll work in the lab and get it working, and you might need to come back to the map and edit that or change that or update that. But we do need to document what our plan is for this network. Part 2 is actually going to the lab room and implementing it in our lab equipment with our routers and switches. And I kind of have a rough task list of cabling up the network, what you need to configure on the switch, what you need to configure on the router, and then what you need to do for your workstations for testing and configuring purposes, if you will. All right, and then down here about troubleshooting. I'm going to keep going. Part 3 then is what you're going to pull together to submit. You're going to submit your router config, your switch config, and you're going to submit your updated or edited network map of this was my solution. This is the plan I put in place. Here's cleanup commands, so you have them for either clearing off your equipment when you start or clearing off your equipment when you're done, or both for that matter. Keep going. The next page or two here, I copied the rubric from D2L on how we're grading this. There's points for the network map. There's points for the switch config. There's points for the router config. I have it broken into 2 areas for basic and more advanced. And then there's an area for functionality testing, showing that everything is functioning and working. Down on the last page, and here's the grade breakdown. Last page is kind of like a planning map. This is just a rough map you can use, lots of blanks in that you can figure out. This is my game plan I'm going to use for my IP scheme, for my ports. What am I going to do? How am I going to do this? So this can give you a place to kind of sketch out your ideas. Then you can take these ideas and put them into your diagrams.net. Okay, coming back up here, you can put your ideas into your diagrams.net. Okay. That'll kind of give you a starting point. That's why I have this down here as like a rough map that you can use to get your ideas out. All right, so there's a quick overview of the network design. We're going to come back and look at details here in a minute. Remember, I also have a link for reminding you how to use the diagrams.net program. There's also a helpful information file. This will be really helpful when you go to implement your design in the lab room. There's lots of config reminders in here about doing this and configuring that. There's useful port numbers here for TCP, UDP, and a link here about private addressing. And again, down here there's a packet tracer file. I downloaded that. Let me open that real quickly. Once you have your idea kind of roughed out, before you get to the lab room, you could actually open this packet tracer file and get a bunch of your config in here and worked out. As I open this, I'll try to get this guy going here. Make him a little smaller. what you're going to see is I tried to replicate what I have on the map for you. I just don't have the connections here. You'll need to make the connections. And I tried to make an ISP over here with a DNS server like Google's 8888. And then I put in here a web server to represent google.com. In this case, I made it 8882, but here's the ISP side of the network. So if you get all this configured and communicating with the DNS server and then able to open google.com, you know your plan is working enough that when you get to the lab room, you have a really good start. So this will allow you to do a bunch of prep and planning and trial. Is my plan going to work? All right, so let's take a look at more detail of what the network design needs. All right. The facility is a branch of a company, Taxes R Us, very much like what we did in 120. There is a handful of office computers, there's a handful of office IP phones, and there's a handful of wireless users. So they need to make sure that each of these groups are, as you'll see, secured from each other. Secured. So we're thinking right off the bat, probably VLANs. They do tell us that there's like 15 of these, and probably, 10 to 15 wireless users in a given point. But they might expect these to grow. So this tells us about port count, but this also tells us about subnet, size of our subnets. It does then say the stations need to reach the internet. So we definitely know we need to have like NAT kind of thing to be able to get to the ISP and over to the internet. It says here stations should be able to receive IP via DHCP, if you will. All this information should be able to get to their nodes via DHCP. So the office computers have that need. The IP phones are going to be similar. They should be able to get their IP as well as their configuration from the router, from DHCP. Wireless users are going to be very similar. Again, they should be able to have get their config through DHCP. And we'll notice that they eventually will need to be filtered, that only HTTP, HTTPS, DNS, and DHCP are allowed. So no other traffic should be allowed on the wireless network. So eventually we'll need to put an access list in to filter those users. Down in here under the ISP area, this is just a reminder, you're going to be plugging into the college network to act as the ISP. That is going to give you a 172.32 address. So I'm putting that in there as a reminder of the ISP is going to give you something 172.32. And I'm reminding you that because you don't want to use a 172.32 inside your network. That would be ultimately confusing. Okay? So make sure you're avoiding that for inside your network, your inside network scheme. That's our needs. So I would take that in mind and use that to build your network map. And that's where you scroll to the bottom down here, scroll to the rough map. Use this as a way to plan out your IP scheme, what you're going to be using for each of the VLANs, basically a subnet per, and what you're going to use for your IP scheme as well as your DHCP scope for all of those. Get that all planned out. Down on your switch, your ports and your VLANs and all that kind of good stuff too. Once you have that planned out, use this to scratch it out if you will. Then plug that into diagrams.net. Plug that into diagrams.net so you have a clean map of your plan. Okay, and again, if you're in your Google Drive, let me go here to my drive, CNT125. I'll go to my labs folder. I'll go to my design lab folder, network design. I can come in here and say new diagrams.net, and I can make a network map showing. There's my blank diagram. I'll do a blank diagram. I can plug in here my routers and switches and everything else. I can go Cisco router kind of thing. Grab my icon here. I'll grab a real basic router, plop it in there, and I can start showing my router to switch, etc. If I need text, just double click. I have the option to put text in. Okay, but show your plan. Show what your plan is. You can kind of duplicate this down here with your details, and that would be a great map to show what your plan is. Okay, do that first, and ideally, you'll want a copy of this that you bring to the lab room for configuring your network. All right. Eventually, you'll need to submit a complete updated version of this to the Dropbox. Getting to the lab room then on the day of implementation. bring your network map to the lab, and you will need to do the following tasks, okay? And this is where I also remind you there's the helpful info file. So let me go back here to the helpful info file. Right here is the helpful info file. This is almost like a quick notes page that can be used for implementing your network design. And here I tell you wise idea before. Get your map, construct your map and print a copy. Get your commands together, get some of your config commands together, have them ready. And in here is a useful resource, inter-VLAN, voice over IP, security, advanced routing. These are all good reference labs for configuration. And again, wise idea number 4, maybe try your solution in the packet tracer. Get a bunch of the bugs worked out before you get here. Once you get to the lab room, then when you go to implement, I also remind you, get everything working. Then worry about adding your access list. Do that last if you will. And remember the whole copy paste from a text file trick. Okay? The rest of the document is helpful information about private addressing, configuration with IP phones, remembering the switch port access, switch port voice. Okay, coming down through, here's remote access or enable password, SSH, console password. I think I have Telnet in here. There's Telnet as well. Telnet, SSH, console. Okay, oops. Coming down through, reminders about DHCP, reminders about NAT. Here's some helpful info for access lists, okay, including our applying. Here's our port numbers that you might need, wink, wink, nudge, nudge. Coming down through, here's voice over IP general config. Here's more specific. I do have reminders in here that Packet Tracer does not like a few of these commands. So just heads up in there. They'll work on our router and lab room, but Packet Tracer does not like them. Here's the rest of our config. Here's the rest of our phone config. And then down here is help on troubleshooting. If I'm not getting, here we are, my PC is not getting an IP, what do I do? My PC is not getting the internet, what do I do? Okay, so this is all good, helpful info. So once you get to the lab room, I'll tell you cable up, but I say you might want to get a bunch of things configured before you cable, especially the IP phones. Do those later. Get everything configured, then worry about applying power to them. Switch, this is the stuff you're configuring. Name IP, enable password to class, remote access telnet, username Bilbo, password Shire. Console password, Bilbo and Shire. Remember, once you create this user account of Bilbo and Shire, you can use it for telnet as well as console. Okay, use that cheat sheet here to help you. That's what these things here are for. To try to jog your memory on how to do that. Okay, console, I can just do the login local to reference that account. VLANs, VLAN trunking. On the router, name, enable password again, access via SSH, console password again, your outside-inside interface, your sub-interfaces, your DHCP scopes, your NAT, and then we do need to plug in some phones. We do need some phones working. And these can be things you add later. Get everything else working, then add this if you need to. We will eventually need an access list. This is the required one to filter the Wi-Fi traffic. And I do have here a bonus access list you can do. A bonus access you can do later for the for the voice over IP. And that's a bonus one you do later. I say, hey, get everything working, and if you have time, then add this one. Workstation testing. Cable PC into your phone, if you will. Cable the other PC into your Wi-Fi VLAN. Power on the phones, and then run through these checks. Check for IP, check you can get to google.com, if you will. IP phones, make sure you can get an IP, call each other. Wireless users IP, make sure you can browse to google.com. Then make sure that your access list, etc., so forth, things sorts of work. I also do have a bonus here of you can add in an access point and get that working. Get your wireless network with an access point. Last but not least is reminders about troubleshooting. And then down here I do have a reminder that make sure I see these functional tests. Once it's all working, make sure I see them. Make sure the VLAN 10, VLAN 30, that sort of stuff is working. Those are additional functionality points. So there's a quick overview of our network design lab.